Good afternoon. Today we are finishing up our Unit 9. We're going to be doing some more with direct variation that we did with yesterday's objective. So CO59 is just taking it a step farther. So CO59, I can find an equation of direct variation given one exists. So just like at the bottom of CO58's homework that we were doing, we were told, yes, there is a direct variation, so fill in the table. So we're being told, yes, there is going to be a direct variation. It is proportionate. So let's review. Oh, Emmett.
Is that the right one?
Yep.
Okay.
Thank
It was
you.
the only one up there. Sorry to interrupt.
Perfect. Thank you very much. Emmett, go get it. Put it away. So we're going to review what we learned yesterday. Let's review it. So every equation with a direct variation will be in what form? What's it going to look? What is our equation going to look like? If we have that direct variation, James, is that hand up? Or are you stretching? Emily.
Y equals.
So remember our slope-intercept form, y equals mx plus b. How is that different when we have a direct variation? Think about all those direct variation slope-intercept forms that we wrote yesterday. What did they all have in common? Mario?
Y equals mx.
Yes, it's just y equals mx. That y-intercept is 0. So it's just y equals mx, not y equals mx plus b, if we're doing a direct variation. Evan? You want to tell me the next one?
Yeah.
The constant of variation or slope is found how, Evan?
Is it y divided by x?
Y divided by x. Let me write that a little bit nicer. All right, so I'm recording. Side conversations are done. This information can be used to not only write an equation with direct variation, but also use that equation to solve for an unknown. So it's one of these cases where we learn one thing and then we build upon that knowledge to do something new. So let's see what that means. We're going to use what we learned in yesterday's objective, and we're going to take it a step farther. So Brian's pay, the Y, varies directly with the numbers of hours he works, the X. Please stop distracting me. If he earns $282.75 for working 39 hours, how many hours did he work to earn $195.75? So we're going to break that down. We're going to take that word problem and we're going to find out what we need to know. So the first thing we want to find out is what is the constant of variation, our slope, the M. How do I find that? Emily. So y equals 1x is our direct variation form. We want to know the constant of variation. Y divided by x. So if I'm looking at my word problem, what math am I going to do? Our word problem is, this word problem is starting off and telling us which is the y and which is the x. We're going to have to figure out the y and the x in future word problems, but this one's making it easy for us. It's saying Brian's pay is y, and the hours he works is x. So look at the numbers we have. What is our constant of variation, Emily? So we're taking the y, his pay, and we're dividing it by the x, the number of hours. So if we have 282.75 divided by 39, what does that equal? Okay,
7.25.
so our M is 7.25. Now we want to know what is the equation in slope-intercept form. How would I write that in my slope-intercept form? Chance?
Y equals 7.25 plus B.
Do I have plus B?
Hold on.
Y
7.25.
equals 7.25x. It is a direct variation. There is no B that we need to put on there. That y-intercept is a 0, so we don't need to worry about it when it tells us it's a direct variation. Don't need to worry about the B. So now we have to do our last step. So the first step is finding your slope. Second step is putting it into the slope-intercept form. And then our last step is you plug in what's known into the formula and you solve it for your unknown. We know the y is $195.75. So I'm going to put that in for my y. That equals 7.25 times x. So now I need to solve for my unknown. I need to solve for that x. I'm sorry, what?
Why don't you do this?
Because b is a 0. When it's a direct variation, that's what we learned about yesterday. When it's a direct variation, the y-intercept is always a 0. So that's the bonus of knowing it's a direct variation. You know that it will always be 0. So if you're told direct variation, you know it's just y equals mx. So what do I have to do to solve for the x? Don't tell me the answer, tell me the math. Aiden S. I need to do those opposite operations. I want x by itself. Right now we're multiplying it, so I need to divide both sides. So that turns into a 1. 1 times x is x. What is 195.75 cents divided by 7.25 cents? Emmett.
27.
Yep. I was just looking at the wrong spot. So my x, which is the number of hours, hours are the x. How many hours does he work? He works 27 hours. So this problem was a little bit easier because it actually tells us what the y and what the x is. Not always going to be that straightforward. So we need to pay attention to how we figure out our y and our x. So I'm going to erase this and scroll up. For each situation below, find the constant of variation, write the equation in slope-intercept form, and use the equation to answer the question. The first thing we have to do is we have to find our y and our x. So remember that y is the output, the x is the input. The input is what we are changing. So let's look at our first problem. The profit Mary earns varies directly with the number of her books that sell. So the profit varies directly by the number of books. So we're changing the number of books she sells. That's what we're putting in, the number of books that she's selling, and we get out of it her profit. So what I do when I do direct variation is I actually go in and I write my x's and my y's. So I don't get confused what my x and my y is. So what you're putting in or what you're getting out of it varies directly by what you put in. The number of books we're putting in is what we are changing. We get a different profit because we're putting in a different number of books. So you put an X over the books, that's what we're changing. We get out of it our Y, her profit. So truly, write the X's and the Y's on it to help you keep it straight. If Mary earns $601.65 for selling 63 books, how much will she earn for selling 59 books? Which one of these is my X and which is my Y? Michael.
The 601, 600, and 601 and 65 cents
Is which one?
is the Y.
Is the Y. That's her profit. So that means that the books is the X. Super important. It is super easy to put them in the wrong way. So you always look. The Y varies directly by the X. Mark it, and then mark which one's your Y and which one is your X, so you make sure you put your numbers in the correct spot. Now, we need to find the constant of variation. How do I find my slope, the M, the constant of variation? All three of those mean the same thing. What do I have to do, Alexis? So M equals Y divided by X. So what math is that for this problem? And what do I get? 9.55. So my second part is my slope-intercept form. So Y equals what? Aiden? Remember, our slope-intercept form, when it's a direct variation, is Y equals MX. You don't have to worry about the plus B because it's always a plus 0 when it's a direct variation. So Aiden, looking at that, our equation is Y equals MX. So what do I write for this problem? Y equals what? What's our M? How do I finish off my equation? Y equals 9.55x. Now I have one more thing I have to do. I have to use the equation to answer the question. How much will she earn for selling 59 books? What do I do? James.
Since you put the books in, so X in, so it's 59. So 59 times 9.55.
Y equals 9.55 times my X, because books are the X. So what does my Y equal? Emmeline,
6.9.
did you do 9.55 times 59? Mario.
$563.25.
So it is important that we look to see what our variable is. If it's books, books are an X, so I have to make sure to put it in for the X. Did you accidentally put it in for the Y, Emily? So always write down your Y and your X, look at what it is, and write your Y's and X's on the rest of your problem so you know where to fill in your numbers. Super easy to make that mistake and accidentally put your Y in for your X or your X in for your Y. The top, the profit varies directly with the books. That X is always varies directly with the X. That will always be your X. Your Y varies directly with the X. That part we know. The way it's worded after that, you have to think it through. What's the Y and what's the X? And then you just fill them in. Okay? Does this problem make sense? Let's walk through one more together. Keeping in mind what we know that the slope, the m, equals y divided by x, and we know our slope-intercept form is y equals mx. What's the first thing I'm going to want to do when I read my problem? The distance Carl travels in a day varies directly with the number of hours he drives. If he travels 270 miles in 6 hours, how far will he travel in 15 hours at the same speed? Woo! Gets overwhelming until I break it down step by step. What is the very first thing I want to do, Alexis? Figure out my x and y. And I'm going to write it on my problem so I remember which one's the x and which one's the y. So the distance Carl travels in a day varies directly with the number of hours he drives. What's my x and what's my y? One person, two people remember what I said? What's the x and what's the y? Emily.
Y is like the distance Carl travels, and the x is the number of hours.
The y varies directly by the x. Okay, so our y is the distance, the miles. So when I see miles, I know that's my y.
Please pardon this interruption. Would all boys baseball players please quietly walk down to the office to pick up your uniform? Boys baseball players.
So if I have any boys baseball players, all you quietly with your chairs because we are recording. So my distance is my y, that's the miles. My x are the hours. So how far will he travel in 15 hours? Is 15 hours my y or my x? X. So I'm going to fill in that 15 for the x. So now, first step, what is my m? How do I find it? M equals what, Evelyn? Evelyn.
601.65 divided by 63. Wait, no, that was the top one, sorry. 270 divided by 6 equals 4.
We know it's y divided by x, so my y is 270 divided by my x, and that equals what, Emily? 45.
I started to get the top one.
So now, my second step, I need to put it into slope-intercept form. How do I put that into slope-intercept form? Tatum. Y equals 45x. Now, I need to answer it. So what equation do I write to answer how far will he travel in 15 hours at the same speed? How can I answer it, Michael?
45 times
Y equals, don't forget that, we're solving it for the y because we know the x, so we're solving it for a y. Y equals 45, filling in the 15 for my x. So what does y equal? Go ahead, Michael.
675.
675 miles. So if we're filling in the x, do we have to do opposite operations? No, because y is already by itself. But if we fill in for the y, we need to get the x by itself. That's when we do opposite operations. So our next page, we have different word problems that you're going to have to do that same kind of math to. Figure out which one's your y, which one's your x, and then do all the steps. So for each situation, find the constant of variation, find that m, write it in the slope-intercept form, and then answer the question, just like we were doing. So do I want you to write your y's and x's throughout the word problem? Yes, why?
Sure.
we could go back and look at it, make sure you're putting your numbers into the right spot. We already saw when we were doing the sample ones that it's really easy to make a mistake and accidentally put the X in for the Y or the Y in for the X. If you label it in your word problem, it really cuts down on those simple mistakes. So I'm not telling you to do that to give you extra work. I'm telling you because I know from experience the simple mistakes that happen, and this is how we can avoid it. So you are going to work on your, let's put our calculators and pencils down, put your eyes on me. You are going to work on the rest of these problems, calm and quiet, coming to me if you have questions or you just want to check your work to make sure you're on the right track, doing it the right way. And then you're going to work on any practice work that you have for retakes tomorrow. So tomorrow we're doing a shorter math retake time because we want to use the silent cheer. So turn your practice work in today. You are going to complete Khan Academy. There's still a lot of us who have Khan Academy to finish. That is due tonight. You're one of my friends with missing math packets. You're working on those and getting those turned in. Today is our last day for missing assignments before the note goes home about after school accountability. So if you're all done with my math, you're checking to make sure you have no missing assignments, working on any possible missing assignments. If you're all done with everything, then you're working on Math Masters, or you're working on homework from Mrs. Gregory, or you're reading that chapter book. But I do believe we all should have Math Masters. Before you read a book, you work on your Math Masters. I believe we still have Math Masters. So with that, my friends at home, we hope you are well, and we hope to see you soon. Have a wonderful day.